All right, so example 9, we're going to solve, and I see a natural log of x, so I know that x has to be greater than 0. And I see a natural log of x minus 4, so I know x minus 4 has to be greater than 0. So we have to pay attention to that. That's going to mess with my domain. On the second one, if I add the 4 over, x is going to be greater than 4. So you should be able to put those two together. If x has to be greater than 0 and x has to be greater than 4, then overall x is going to have to be greater than 4. So the domain on this problem, greater than 4, means from 4 to positive infinity. If I'm solving, I'm going to need to put some natural logs together, and so we can use the properties from before, and we know subtraction is going to get translated into division. But also what you should notice is we've got a natural log of e, and that's going to cancel out. Natural log of e to the natural log of x. The natural log e is going to cancel out, leave me with just natural log of x minus natural log of x minus 4 equals natural log of 5, which is just going to be a number. This subtraction I'm going to condense into a single log by changing into division. So natural log of x over x minus 4 equals natural log of 5. To get out of that, I can get rid of the natural log on both sides by taking an exponential base e. X over x minus 4 equals 5. Now it's just a simple solve. I'm going to cross multiply. X equals 5 times x minus 4. So distribute. X equals 5x minus 20. Subtract 5x over, so negative 4x equals negative 20. Divide by negative 4, you're going to get x equals 5. Now, as long as that fits in the domain, you're good. And 5 is greater than 4, so that answer is going to work. X equals 5. Example 10. Newton's law of cooling is given right there. It says solve for k. So we just want to isolate some variables. Let's subtract t0. Any of this you can do in your head would be awesome. So t minus t0 is equal to c times e to the negative kt. Divide by c. I'm going to switch it around here. E to the negative kt equals t minus t0 over c. I need to get rid of an e, so we're going to do a natural log of both sides. Negative kt equals natural log of t minus t0 over c. And now I need to divide by the negative t. If I want k by itself, I'm going to divide by negative t. But we're going to do kind of a math trick. Instead of division, we're going to think of that as times negative 1 over t. So the t is going to cancel and the negative is going to cancel, leaving me k equals, but I would have negative 1 over t times the natural log of t minus t0 over c. This next slide kind of sums up the different things that we can see. Bullet point number 1, if we had a problem like 3 to the 2x equals 4, we're going to take a log of both sides. And the second bullet point, if we had a log base 2 of something, we're going to take an exponential on both sides. If I've got log equals log there, okay, basically I'm taking a log both sides, but it's going to cancel out. The log cancels out, that is. Number 4, something complicated like that, you might have to end up using the properties. Use your properties to simplify. And then number 5, check that each solution is in the domain. All right, you're going to forget that, but you can't. Okay, you've got to remember to check the domain. Number 11, this table gives U.S. tablet sales in millions for several years, and it's modeled by that function, where T is the number of years after 2009. Part A says use that function to estimate the number of tablets sold in 2011. So T is going to equal 2 there. That's 2 years after 2009. So really all they want me to do is plug in 2. F of 2 equals 20.57 times the natural log of 2 plus 10.58. I plug this in the calculator and I get somewhere around 24.8 million. And then it says compare it. How does this figure compare to the actual figure? Well, the actual figure was 24.1, so that's really close. It's really close to the actual figure. B, if this trend continues, when will annual sales reach 58 million tablets? So that's going to be on the left side of the function. 58 equals 20.57 times the natural log of x plus 10.58. So subtract the 10.58, we're just isolating here. $47.42 equals 20.57 natural log of x. Divide by the 20.52, or 57 rather. You get about 2.305 or so. So we have natural log of x is about, I probably should use this, 2.305. And in order to solve this, we need to get out of the natural log, so we're going to do a base e on both sides. Base e, we want to do an e to the whatever that number was, because we've got 10.03. X is about 10.03 years. And so we're talking about after 2009. So 10 years after 2009, about 2019.